All right, the meeting is also recorded. Okay. So starting with the first part. Okay. So the first question says list the elements of each of the following sets where P, so we have P with the set numbers such as 1, 2, 3. What name of the set are these? Where we have like just 1, 2, 3, 4 until infinity. How do you call this set of numbers if I'm to ask? Natural numbers. All right. So these are natural numbers, right? So natural numbers, they start from 1, 2, 3, like that, going like that. Okay. So now how do we solve this one? So what you are going to do is um they want us to list list the elements of each of the following. So there's a condition upon us listing, there's a condition given there. All right. So this condition means that we need to list the numbers that are between 3 and 12. Okay, but those numbers, they should be less than, so here they should be greater than 3. So x is greater than 3, and again x, those values that will be listing, they need to be less than 12. That's the meaning there. Okay, so all the natural numbers, like we are supposed to have 4, 5, 6, 7, 8, 9, 10, then 11, then 12, like that. Okay, so these are the one we're supposed to have. These are the set of natural numbers. Now they are saying we don't have to put, we don't have to, those values, these natural numbers that we list, they are values of x. Okay, then what they are trying us to communicate to us is that you don't include the 3, because 3 there, unless if we had something like that down there, that's when it would have been, it would have been in um it would have been included like that. Okay, sure. So what we do here then, this means that we say we have these numbers. So x, where it is greater than 3, it is only at 4. You have seen? You have seen? And again, until they said we don't have to include 11. So the numbers that we include for A will be x. So say the element of A are A, we have 4, we include 4. Then we include the list, like we have 5, we have 6, we have 7. And give me the other numbers. Tell me. Good, good, good. Yes, so we just include 11. Very good. So we don't list other numbers. So this actually proves that we have listed the elements that are greater than 3 and also less than 12. This is the meaning. Is that okay? Is it Abishai, your friend? Is it Abishai what? Oh. Okay, okay. So he should be talking. He should be saying something else as well. Sure. At what's his name again? Abishai, are you getting me? All right. So that's my sister. Should take care of her, okay? Yes. So that is it. Now coming to B, we need to list. So this is B. This is B. We have to list again the element. So looking at also what the condition that we have been given to say X, we list those element of X, and so you should just be following. Like you try to mute the mic, you put it on while, I mean, once you are talking. Okay, sure. So X is a member of P, and the condition given is that X should be an even, and those evens should be less than. Yes. What's the first even number? Or first, what are even numbers? Great. So like we start from 2 itself, right? Because we can start from 1. 1, can you divide 1 by 2? That can't work, right? So this means that the even number we first have is 2. We divide 2, we don't get to have a remainder. Again, the next is what? 4. Good. The next is what? Good. The next is what? 8. Next is what? Good. Next is what? Good. Next is what? Good. Next is what? That's all. Good. So this means that we have rested with this condition. We are now less than 15. Would have included 15 if there was something like dash there. You get me? So that is it about this one. So if I'm to ask you so that we go to the next question, can you fail to list this one? Yes. Okay, I get the point. So what you need to do is first see there's an equation, so you need to satisfy this equation. Okay. Yes, we can be listing. See, I suppose I list one there, I bring one there where there's x. It will be 5 is equals to 3. Is that true? Like if I'm to get this, so because that is an equation that we have to satisfy. So we have 4 plus x is equals to 3, right? Getting these values that we have been given, these values 1, 2, 3. If I'm to try 1, so to be 1 plus whatever the x, I'll put 1, then that will be 3. So that will be 5 is equals to 3. Is this true? Is this true? Is I'm saying, okay, let me just revert. Let me just go back to that. Okay, what I'm trying to say, there's an equation. Wherever you see an equation, just know that things must be equal. So now what they have been given, we have been given 1, 2, 3 as elements. So we need to substitute in this equation. This is an equation. That's why there's an equal part there. So what we are trying to say is um, we have 4 plus x is equals to 3. So now getting one element, suppose I get any element, I try 1. So if I put 1 there, wherever there's x, I'll put 1 there. You see? Again there, this will give us 5. Is this true? Is 5 equal to 3? Is 5 equal to 3? So it is not. So you see? So this won't work out. There's no element. Like C won't have any. Even if you try 3, try 3. I mean, try 2. If you put 2 here, it will be 6. Is 6 equal to 3? Okay, so we don't get any element. Is 3 equal? If we were to put 3 there, we add 3 plus 4. What would be that? It, not equal. So meaning that it doesn't have like it's an empty C is an empty set on these elements. You get me? So yes, how do you how like there are no element, there are no numbers that can be actually be computed in that. So let me just see show you how you should approach this. Um, all right. So the way you should approach this first, what you need to do is you get the whole equation. You can't just start it like that. So simplify if possible, whereby you need to have just x, just like we have been having this condition. You get. So now you solve this. Once we solve here, what will be the value of x? Give me -1. Good. So Fio. So that is it. So this means that since one, I mean, since x must be positive, we need x to be positive. These are the elements that we need to have because it was saying x is a member of P and this P, they were going like that to positive infinity, positives. Okay. I'm just trying to show you to say this is actually what you need to have for x. Don't get confused here. Yes, like yes, we needed to have negatives for us to satisfy this because if I'm to put -1 there, that will be -3, which is equal to negative what? Like if I'm to put negative 3 there, negative 1, because the value of x that I've found is negative 1. If I'm to put negative 1 there, it will be 4, then plus negative 1. You see? Which give us 3. Yes, it will be 3 is equals to 3. You have seen? Mm-hmm. So, so here you just explain to say since x must be negative, okay? Since x must be negative 1, okay? There is no solution because what we have there, they are just positives, and the needed answer to satisfy that equation was supposed to be negative 1 only. These are the things is like suppose you have, let's say, I give you to say 2x, or let me just say a 6 yearly 8. So suppose you have like a 2 plus x is equals to 4. You have seen? Yes, you want to satisfy this. So if you are to take that one there, it will be x is equals to what? No, I just want you to be very fast. Like you just x is equals to 2. So this means that x we need to put 2 there so that we satisfy this condition to say 2 plus 2, that will give us 4. You have seen? That's how you should approach this. First, solve and see what actually x will give. And those are the values of x that you need for you to satisfy this. When you substitute there, it will satisfy this equation. So you solve. Yes, yes, that's what you need to do. Is that clear, Abshai? All right. So that one was, yes, complicated, but I want you to say something before we go to the next one. Here, I just want you to say something. What should we do there? Here on D. So this we have tackled, then D. What should you do there? Okay, so what you say is since um since x, okay, is equals to negative, okay? Yes, and the p element are positive. X must be positive. Okay? You're just explaining what is happening here. So you say since x is negative, okay? After solving the way you solved, and the p element are positive. We have one, two, three, positive infinite like that. This means that there is no solution for set C in short. Set C doesn't exist with this element in this condition. Is that clear? So therefore, you say C is equals to empty set like that, or you say C is equals to empty set like that. Is that okay? All right. So then coming to set D, what do they mean here? X is a member of P. Yes, we have those P elements, but X is a multiple of 5. What are multiples? Yes, Abishai. Okay, so what you do, multiples, those are numbers like when you multiply this 5, you get those answers. Like you multiply 5 with anything, then you get those answers. We start with 5 times 1. 5 times 1 can give us what? 5. Again, 5 times 2, you go like that. 5 times 3, 5 times 4, 5 times whatever infinite you get. So here we can have 5 times 2, 5 times 3, 5 times 4, 5 times 5. Just like that, you go like that, you list like that because they won't end. The multiples, they are a lot. Okay, whatever number you multiply with 5 to get whatever, that will be a multiple of 5. Like it's just a product of whatever number you multiply with 5, then you get that number. It's a multiple. Is that clear? All right. So, all right. So Here I'll do two, then the rest you should do. Or I'll do also this one, which is complicated, then the rest you do them, okay? I'll need the homework. You get me, Abshai? Sure. So what you are going to do here, the question says in the problem below, one of the following relations is true. So we can have a condition at which A is a subset of B, and also A is equal to B, and also again A can't be equal to B or B can't be equal to A, and again we can have a situation where B is equals to is a subset of A. What do I mean when I say subset? A subset is simply means suppose I have set A, set B like that. Then inside there I have set A as well. You have seen? Let's say there's a 2, there's a 2, no, let me say there's 3 there and 4. This means that if B had the element, B will have 2, 3, 4. You've seen? Then A will have just 2. This means that the element of A are found in B. So meaning that A is a subset of what? B. You have seen? Is that okay? Yes. And if I'm to say again, this means that also B, all the elements of B are not found in A. So we'll say B is not equal to A. You have seen? Because these elements, they are not equal to 2. Okay? Yes. So those are the things that we'll be experiencing here. Again, if a situation we have this one is not there and also this one is not there, then we have two like that. Then that would be A is equals to B or B is equals to A. Is that okay? In a situation whereby they are equal. So that's what we'll be doing here. We'll be trying to solve the given equation and see whether they are correlating. Is that okay? Very simple. So at the end of this, I'll need you to submit properly without even any Googling. I want you, after I teach you like this, then you should submit the work like whatever time, like tomorrow or any day that you'll be free, but I need it. I want to see whether you're understanding these things. Then I'll just submit myself. Messi wowola ndio ha. All right. So those are the things we need to bear in mind, guys. So now, starting with our first problem, you see, there's a relationship that will be actually obtaining B and A. You see? Sure. So what I need to do is, what you do is first you solve this one, you solve the way it is, and also you solve this one the way it is. Is that okay? Okay, so we get this one, the first one part. So say A. So we'll say 2x, okay, plus 3 is equals to 11, right? 2x. So this means that if I'm to solve this one, this can come to this side, or you choose. Tell me how should we solve this equation? Or let me bring 12 here. Then it will be positive, right? I mean this 2 here, which is here. It will be positive 4 with this, right? Yes. Then this one, it will be 8. So you divide that, the x will be what? And 0. Well, these ones, you don't have to be very be sharp. But just by looking at it, you'll be able to see. The B part, let's see the B part. The B part, we have 5x plus 4x. Okay. So this means that what are we doing here? Like I bring this x here, it will be 4x, right? Then there it will be 8, right? Good. 2. You have seen? So answering this question here, the answer that you need to put is A is equals to what? Good. Is that okay, Abishai? Thank you. So this means that A is equals to B. All right. So I want you to tell me what will happen also on this one. Is that okay? I want you guys to solve. Like I want to solve from here. So let me solve number 2 on this one. So let's solve number two, like this one. Okay, let me use a black pen. I like black pen. Which one is good for you? All right, good. So we go now, like we are solving this part of A and also solve this part of, because this will involve a bit of quadratic. So let's see. So we have x there squared. I'm just solving this part, then I'll come to this one, then we'll compare. Is that okay? So we have 4x there is equal to 4 like that, then minus 5x. Is that okay? Good. So how do we approach this one? It's an equation, like a quadratic equation. How do we solve it? So let me just group it like the way it is. You put in that form of quadratic. Where you have seen. All right. All right. So yes, what are the two numbers? When we add them, we're getting 5. When we multiply, we're getting what? Good. 4 and 9. Yes. So when we add 4 and 9, so say we are getting positive. So meaning negative 4 and positive 9, right? These, they are giving us 5. Again, when we multiply these two guys, they are giving us what? 36. So good. What we do is x squared. We just bring the way they are there. Minus 4x, then plus 9x. You have seen that these, all these two guys are the values of 5x. There's nothing we have changed. You have seen? Good. That's mathematics. So then that is 36 is equals to 0. So what we do is, if you see that there's no number here, the same numbers you have found are the values of x. Is that okay? If you see that there's nothing there, like I mean, if there's nothing on the coefficient, just know that the same one you made, they are the values of x. Is that okay? Yes, the way you found them. In fact, let me not even do that to say what is common there. I'm just telling you direct right now. Is that okay, Abshai? Yes, we are growing, guys. So I don't have to say what is common, Shanisha. No, that will be the same thing you found there to say. You just say x minus 4, the way you found them there, and x plus 9. Is that okay? Yes, good. Then there's equal to 0. So this means that when you take that one to the other side, that will be x is equals to 4, right? And we have again x is equals to 9, right? Yes, so these are the values of x. So now I've found 4 and negative 9. Let me see also this part, this part. Is that okay? Do you copy? Very good. So that's what I want you guys to get. Yes, I want you to be used like in the way. That's how lecturers are moving. They will be leaving some steps. They leave, in fact, not they'll be leaving. So from there, then we solve also this part because I've solved this part there. Okay? So that would be 3x. No, that's not 3x. All right. So 3 plus 2x is equals to 11. So this means that we have 2x is equals to what? So meaning that x is equals to what? 4. You have seen that this is b, right? And in the set, see how it is now like getting interesting. I want you to give me the answer at the end. See how it is getting interesting. I want you to see the logic which is here for the final answer based on those options you have been given. Okay, so based on those options you have been, now it's learning here. Tell me if it will be noise, eh? Okay, so All right. So it's more like A. We got A. We had element. A. We had element. These are the one we found from A. You remember it was a quadratic. So we found what? And D? Yes, 4 comma negative 9. Then on B we found what? 4. What does this mean? According to this condition, which one can we apply here? Tell me, I'm listening. I'm listening fast, fast. A is a subset of B. Tell me, be confident. No, it's clear this one. So hey, give me now the final answer. You have explained. Give me the final answer. So you tell me if it's noise because it's raining here. So if it's noise, then you tell me. Then I will pause. You able to get me? All right. So um, tell me the final answer now. You are able to get me clearly. Okay, yes, B is a subset of A because the members of B can be found in set A. You have seen? And the same A and B, they are not equal because this one has a lot and this one has only one number. You have seen? Okay, so this means that B is a subset of A. Okay, that's what you do to this one. You solve also this part, you find that it's a quadratic, you solve a quadratic. Also here it's a quadratic and you see from there. Then are you confused with this one? Is this confusing? All right. So what you do with this one, here you combine the two. Okay. So you solve here. Okay, let me solve it for you. Hi. All right. All right. So what we do here is you solve the elements that are here, okay? So for D, you say the element that we have there, if I'm to solve this one, I have x is equals to 1, right? I'm done with this one. Then if I'm to solve this one, we have x is equals to what? Yeah, so this means that the first A of this one has element 1, 1 comma 2. Is that hard? Yes, from here then here you solve also quadratic and to determine whether it's hard, it's simple or what's it. I mean whether they are equal or they just subset. Suppose, let me just give you a hint as well. What will be the values of x here? Since you now know when it is when there's no number there as coefficient of x squared, the product is what? So you find that what are those two numbers? 1 comma negative, just they are negative like that. Yes. Yes, so what you do, it means that x minus 1, like that. Then again, you have x minus 2. So this means that we have x is equals to 1 and x is equals to what? Is that clear? Or someone is lost? At repeat again, just say repeat. Abe babulungu tibamwiha English. Anyway, what I'm trying to say is, I said, whenever you see that x has just like no coefficient here, go direct to those products, okay? The factors. So the way they are there, it's negative and shan, like that. So you say x minus 1, that will be the first part. The other part is x minus 2. This thing, they are supposed to be equated to 0, you have seen? This means that what we have here, it is equal to 0, and also what we have here is equal to 0. So that means the x minus 1 is equal to 0, comma. We have x minus 2 is equal to 0. So this means that x here is equal to 1. X there is equal to what? So now, you have found again the same thing for b. You have seen? Yes. So a is equals to b. So you conclude to say a is equals to b, or b is equals to a, which is the same thing. Is that hard? All right. So that's the, for this one you do it also. It's very simple. Here it's a quadratic. You will see, but mostly here it's giving one value. Here you get two values. So this one is likely to be a subset of this one. Okay. At at what? Yeah. Waziriwa. Well, this one, in fact, the way to solve this one, if you want, you can expand, or you can use the indices, whereby you take that half to 16 and you give you 4. And in fact, it will be very same. Yeah, I think that's the best way to solve it than you expanding it. Let me show you. The way you can solve this one, you can say, you can introduce the root there, okay? And the root there. This will be cancelled. Or what I'm trying to say, you have x plus 3 to the power 2. Then we have, is that okay? We have 16 like that. So I can multiply this times 1 over 2 to cancel this 2 and this. And also here 1 over 2. You have seen? So this means that we have x plus 3 is equals to, it's more like it's in the root, this one. That's the meaning of half. Or you can say 4 to the power 2 times 1 over 2, which this will cancel. Is that okay? Yes, the root simply means it's half. So that means we have 4 there. Is that clear? Is that clear? Okay, so when you solve here, you find that x is equal to what? 7. No, 1. What will be the value of x? Yes, x is equal to 1. And if you are to solve this one, even x is equal to what? You find that, yes, you find that this will be contained. Is that okay? But try to solve it in this way, like you square like that. Is that okay? I think it can be a subset. Try to solve that one and you give me the answer. I think that can be the best. All right. So here will be very fast. Are you able to get me? It's learning here. You are getting me clearly? All right. So here, consider the following sets. We have empty sets A, B, and C, eventually even D and E. And universal, it has element from 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that okay? Insert a correct symbol between this one and this one. Is that okay? This simply means it's not a subset. Is that okay? Yes, between each of the following. Between, we'll be putting whether this one or this one, a subset or not a subset. That's all. Okay. So if you are to ask it to say, find the number of subsets, given that set A, let's say, has elements A, B, C, D. Or let me just put, okay, these are enough. Then I ask you to say, how many subsets are there? Okay, again, I want you to understand the meaning of subsets. Suppose I give you set A has these elements, okay? Then I ask you to say how many subsets does A have or contain? Okay, I'm asking to say how many subsets does A contain when given that it has two number of elements? Okay, always the number of subset is calculated by 2 to the power n, where n is the number of elements. We learned this. So this means that 2 to the power, how many number of elements are there? So this means that we have what? 4 subsets. I can do this. This is how you bring subsets. So the first subset of a set is an empty set. The second is you put this element, which is A, alone. The third one is B, alone. The fourth one is A and B. You have seen? A and B same as B and A. You have seen? So they are 1, 2, 3, 4. Which is this one? Yes. So whenever you ask how many, list the subsets. You start with the empty set, then you start single digits, then you combine the digits. They shouldn't be the same like A and B or B and A. Okay? Is that okay? Yes. Yes. I wanted you just to get that logic, but now listen. We have empty set there and A. First, we start with A. Is empty set a subset of? I'll try between these two, right? Let me start with this one. Let me start with this one. Is which one is the subset of each here? Yes, an empty set is a subset of A because an empty set is there. You have seen? Yes. We can't write this unless if it doesn't satisfy this. But each set has a subset. So long as there's an element in it, it has a subset. Okay? Then A and B. You can see that one is found in B. You have seen? Is that okay? So this means that what's the mean? A is a subset of what? Good. Uh, then C, B and C. What is happening between B and C? Wait, can we have, wait, wait. For you to say it's a subset, it need to contain all these things that are here. They should be found in this. Is that okay? Not only one number. Hey, like it should be. That's why I listed to say you have something there and also something there. So if it's 2 there, then there are 3 and 4. It means that if this is B, then this is C. It means that all the, let's say I can list also 1 there. You have seen? For B to be, it's a subset of C. Why? Because it contains all the elements in which are in C. You have seen all the elements in B are in C. If I'm to list C, 1, 2, 3, 4. Then B, 1, 2. All the elements they should be in the other set to be the mother set. Is that okay? Okay, so what will be the relation there? Yes, so what will be the answer? We have this set and this set. Between these two options, which one are we putting? So we can say B is not a subset of, it's not a subset of C. It tried by all means to be this side as if it's a subset by having a virtue of 1, which is 1, but it doesn't qualify. Is that okay? That's why I've put this. Is that okay? Is it clear there? Okay. Absa, is that clear? Okay, let's go to this one now. Then the rest you do. Tell me what will happen between B and E. Always a set is a subset of universal. Is that okay? Any set, because we can't have universal minus having the members of the sets. So here you know what to do. Eh? Yes, this is the mother. In fact, all the sets they are subset of E. All these sets that we have they are subset of E. All right. So going to be C and D. So if you look at C and D, what is happening? First, so that I can control you in case you make a mistake. Wait, at what? C is not a subset of, okay, we can see 1, 5, and 9. Then we have 1 chance something there. So this one has a lot of elements, right? So these elements, they are very few. They try by all means to be in this set, but it's failing. So say C, we say C is not a what? I. Okay, what about this one? This is correct. I is a subset, right? Every element is a subset of universal. Is that okay? Just like this one. Also, this is correct. Also, this should be a subset. Is that okay? This U is also same as universal. Wait. I was making a mistake. I'm sorry. Wait. I've just I thought this E would represent universal. Can't they have used U? I'm sorry on that one. So you need to do what is there. There's also set E. I didn't pay attention that they said set E there. Okay. So you do the right thing by starting from here to say B is B. What happens between B and E? You find that 1 and 3 they are found in what? In E. You have seen? So B will be what? Good. So each equal to this one, you do the same. You also judge there. You also, but this one is true. Is that okay? This is the only one I was talking about to say all the elements are subset of this guy. This is the mother. Is that clear? Yes. So this is the mother to Abishai, which is Muyokera. Ah, that's your mom. She's older. Tabakulafya abo, otherwise bakulu. Ni banakulu abo. Okay, that is it, guys. Let's go to the other one. So I need to be very fast so that you find time. Is that okay? Yes. So all right. So we have this one. So here what we do is let U be the elements. It has a lot of elements to positive infinity. Be the universal set, and let A have this one, B have this one, C have this one, and find A intersection B, A intersection C, A. These I think they are for children. Eh? With this one, right? Yes. So here, guys, there is what we call De Morgan. All right. Sure. So this and in set simply means what? And in set there is word O and yes. This one simply means you. This one simply means intersection. Is that okay? That's the language you need to know. Okay. So this means that we have A intersection C complement like that. Is that okay? So what you do is in the universal, since the universal that we have here is not listed. So what you do is you look at the last number in the set you have, the biggest number is 9, right? So equal universal will have something like 9 or 10 like that. You can put 10. Is that okay? So the other way of solving this one, you can say this is De Morgan. You learned about De Morgan's, right? Okay, De Morgan's is talking about you'll be proving, of course, if you have A intersection C like that, this is equal to like De Morgan is about just this the effect of this complement. You distribute, you multiply this time that will be A complement, right? The moment this complement crosses this, whatever, whether it's union or intersection, this has to change to, if it is intersection, to change to union. Yes, so like that. Is that okay? Yes, so this is De Morgan, in fact. You asked to prove that. So even here, I can change this one. This is same as you just simplify that you simplify to say A union. Is that okay? C. That's how you can list that. Yes. Is that okay? So if because this when you distribute this complement again, it will give you the same one which you had there. So you can just get at this point to say A union C will list those elements, but A union C union, by the way, it's more like plus. So we add all the members that are in A and all the members that are in C. Then the complement. We don't want those ones which are, so what we do, the complement are those which won't be found in this list. So if we were to get 1, 2, 3, 4, 5 until 9, plus from A we have 1, 2, 3, 4, 5, 6. You get. So we list them to say we start with 1, the list. We have 2 in both, 3, 4. 4 is not there. 4 is not, is 5. You have seen? So we said you can list the universal it was given, it was an infinity. They didn't, we can say the universal ended at 10. Is that okay? So what I'm going to do is this, we are talking about the complement of these. So you list all the numbers but not found in this. Okay. So those numbers that are not found in this, we can talk of. Um, 4, of course, is missing. There is missing. But what I'm going to do is Since 4, it was supposed to be listed there because it was going like that. You have seen to 10. Is that okay? Or even if I don't show 10, I don't show 10, what I'll do is I'll say it was ending at 9, but um I will say it was ending, even the universal equal ended at 9 because of the largest number we have there. So I will just list the 4. It's the complement of all these because it wasn't there. Is that okay? 8, 8, 8. Okay, 8 is also there. Good. These are the numbers that are missing from this. Yes, from these are the numbers that are missing. Is that okay? Okay, that is it about this. An intersection where. Okay. Let me also show you on this side, like just applying this one the way it is like this. You find that we find the same answers. Okay. Yes, let us do the way it has come now without applying the De Morgan thing. Like the way just it came. Aye. Yes, because we just wanted to solve it in the other way around. You see that it will come out the same. So what I'm trying to say is we have C A complement, right? Then we say this is intersection, right? Hey, at this point I'll leave it like that. Okay. So I'll list the element of A complement, right? A complement are those ones which are not found in A. So I'll list it to say we just exclude these ones. So we have 1 is not there because it was there. In A is there. So the only number which we don't have between in A with 4, right? 3. Give me what are those numbers? 3, 4, 7, 8. Yes, we can include 9 because it was included there on C. So we'll do this. Then intersecting now. Let's go for C complement as well. Here, what is lacking is just the 4 and what? 8, right? So we have 4 and 8. You have seen? So we are intersecting. What is like intersecting? What is common between this side and this side? Where they intersect, where they meet, they'll meet at 4 and also at 8. You have seen? So we have 4 and 8. You have seen that we are getting the same thing. So you can approach in this way or this way. But this way is best because here you confuse things. I Abishai. All right. About this one, right? Okay. At first, I used the Morgan. I don't know if you understand it, but I believe you learned about it. But on the other side, I used the normal way that like the way it came. We use the union here. We this is what we use the union. uh Or you okay? Wait, you want the other way around, or you want the answer for this one? Okay, just in case it comes like that. All right. So if it is to come like that, then that will be, you mean we get to have A complement, then union C complement. Okay, still the same. Still the same. What we'll do is you can again approach in different, whether by using De Morgan where you get to solve like this, where there will be intersection here, or you get the way it is. So which one do you want? No, let me get the way it is. Okay, so we are listing elements that are in A complement, right? What are those elements? Besides these, so we have four, right? Three, four, seven, right? Union. So what are those in C that are not found in C? Two, four. What about six? Yes, we have two, four, six, eight, and nine. No, yeah, that's so, that's so, that's so. So here we are uniting. So you get the list number you have, which is two. Again, you look, the following number is four. Is that okay? Okay, three. All right, it's three, yes. So we have three, then we have four. We have what? We have seven, eight. So this is what you get in the other way around. It can be the same. This was union, it's adding. So you can also approach it in the De Morgan way. It will still give you the same one. Yeah, where you say this one is equal to A intersection now C cross like that. Is that okay? You still get the same. Is that okay, Abishai? Yes. Yes, yes, yes. You find that you are only removing the intersection of A and C, and the rest you list them. So the intersection of A and C is what? Here, if I'm to solve this one, the intersection of A and C is what? Where do A intersection with C? You find that at one they're intersecting, meaning that you are getting one, you remove one, you won't include. Then again, where I was at five, right? At five, they are not meeting also. You don't need those. What else? Yes, if you are to solve in this way, you list A intersection C complement. We have yes, yes. You find that yeah, you find that five, well, like one is not there in this set, and five. You still get this. You have seen. I wasn't even supposed to solve this one. I wanted you to solve. Okay, you will give me this. One, two, three, four. Equally this. Is there a problem here? No problem, right? Unless maybe this one, but you just distribute this complement. I've told you how to distribute, right? You learned about distributive property, associative properties, just like that. Yes, so here you do it the way you approach the way it is. Yeah, good. So we go to this one. Is there anything which is challenging here? Question number what? This one. This one, guys. Them or this. Okay, what you need to know is that if I have A minus B, this simply means that A intersection B complement. Is that okay? So here what we have is we have A minus, is that okay? I can make this one like I said, it is B complement. Is that okay? Again, if I'm to solve this one to say A minus, I can say complement. I mean intersection, then we have this one inside. I don't disturb anything, but I've put the complement because of this what I've put here to replace this. So this has made this one and this one. Is that okay? You are lost. If we have a number to say A minus B, this can be written as A intersection B complement. If you have X, ah, okay, this if you have X minus Y, this can be X intersection Y complement. Is that okay? Sure, we can prove that, but that's not our area of interest. I guess you learned or you solved at some point. So this is how it can be achieved. So you can distribute now this when you distribute inside there, it actually wait, wait. Okay, we are here. Okay. So we have A, which was minus. Now it will change to intersection of what you have complement, right? This one we already made it. So the complement is there. Have you seen? This one, this intersection has came up with this to replace this one. Mhm. So just like I said before, say this one minus, suppose this whole thing here, it's B. So to relate to this, you say that A which you had, which is independent, minus you put the intersection, then complement of that B you had there, which is our B is this one. That's why I've put a complement. All right. Abshai, are you lost? Data boy. Data boy baba mlyokera mukanda. Atishani wa data boy natudatuluka. Okay, okay. What I'm trying to say is if you have something to say, suppose you have X minus, okay? Let's say I have A plus B inside. This can be written as X intersection, this what I have, A plus B, then complement. Is that okay? So this is what I'll do. I'll have A minus, open bracket. Is that okay? I'll say A minus B. I've changed nothing. So what I'm going to do is I can make it at this point before making what is inside. So I'll say A intersection, open bracket, A minus B, then complement. You have seen, because of this, I've put a complement, then I mean intersection, then complement there. I've not changed anything inside there. Is that okay? uh Now I'm going now to solve what is inside. Is that okay? Also do the same. A intersection, B complement, like that. Then that complement, it was already there. Then what you need to know is this is arbitrary method of De Morgan. Suppose I have complement there and complement here. This will give me a complement. Complement times complement. It's more like negative times negative to give you a positive of which you can't see there. Okay, so if I'm to distribute this, so we'll say A intersection, open bracket. We have this one times that, it will be A complement. Is that okay? Are we there? Then this means that we have A, Wait, by the way, we said when an intersection, I mean the complement crosses the intersection or, so that will be again, this time that it will be just B, right? Good. Is that okay? So we say now, what you need to know, these are set laws. If you have A intersection, A complement, it's more like we are intersecting set A and nothing. Is that okay? What are we getting? Like zero intersecting with something. It's more like we have A and we have universal like that. We have set A there. It has something like 2. Then there's also an empty set outside there. Is that okay? So do in short, if I'm to bring like a set and an empty set, this set doesn't have anything, and this set has 2, which is common in it. Where do they intersect? They will intersect at this empty. Doesn't like they don't have something in common. Is that okay? So I want you to know that A intersection A complement is always empty. And again, what I want you to know is that while you are solving this is A union A. This can be any other set. I'm just writing A. Is that okay? So this would be what? This would be still A. Is that okay? No, this one A union. Okay, I'm coming to that. But so far, these are set rules that you need to know. Is that okay? A union A, should give you A. Why? Because it's more like you get in A there is 2, and also in other A there is 2. You only report one number. Yeah. So if you have A intersection universal, this should A will intersect with universal where there is A. Is that okay? Suppose this is the universal. If you are to shade this, A will intersect with universal where there is A only. Is that okay? Clear? Isaac, clear? I mean, Abshai. All right. So if you have um, universal complement, this should be give you an empty, because outside the universal there's nothing. Outside the universe there's nothing, right? Only the Saturn is found, and the Saturn doesn't have sense. So Saturn is empty. Is that okay? And also, if we have empty set complement, what is not found outside there? It is the Earth, right? Which is the universal. Is that okay? So these are the set laws that I wanted you to remember. And if I'm to unite, let's say A union universal. I haven't given you this. This always is universal. Is that okay? Because you report the biggest number. It's more like you're adding A add 2. Then this one has a lot of 2, 4, 6, 8. You report the same, which has a lot of things. The universe. Is that okay? It's more like I'm asking you to say, what is where does Mwekera stay? He stay in Lusaka. In Lusaka, suppose specific it's Unza, but because of Lusaka, Unza is found in Lusaka. I'll just report Lusaka. Is that okay? Because I'm not interested where they are meeting. They are meeting at Unza. If I was to, like this one is saying they are meeting at Unza because she's at Unza. Now that we are bringing the Lusaka and Unza, we just say Lusaka, which is big. You get it? Coming back to our question. So I'm saying A, we distribute A intersection, you multiply with that, that will give you A intersection complement like that. Is that okay? Union, open bracket again, A intersection you multiply times B. This one is our separation. That's why I'll put it like that. So say A intersection B like that. Is that okay? Is that okay? Okay, so this means that at this point now, we know this. What is this? So empty set plus something is still that something. Is that okay? University, wetata. Okay, is that okay? Is that okay? All right. Okay. Um, is there a problem here? Okay, if you are clear, test me on the first one. What would be the answer? I'm listening. Tell me what is the answer? Wadaturuka. And these are simple. You guys, so get me clear. I'll explain this one, then the rest you do them. So they are saying use the bracket these ones or these ones. So if you are to look at there's a dash, it means that the range of x is 7. Okay, is that okay? Is 7. By the way, these are what you call intervals. So intervals, if I have like it's closed, this is closed, this is open. Is that okay? Suppose I have 2 there, then I have 4 there. The way you represent using the brackets, you say it's closed there, so you write these brackets, then it 2 like that, comma. Here it's open because of this circle, so you write 4. Then this one seems open. This simply means open. Is that okay? So for numbers like this, it's x is closed to is it's shading 7. So for the first one, I'll say we have 13 and 7. Is that okay? So you can see that x is equal to that 7. So I'll shade on the 7 there. Then here it's open, you round like that because it's not equal to that. Yes, I'm just showing you how to present it because of by virtue of you having this one, it means you are crossing on the number line. Then this one, it's open because of this no, it's less than something like that. Is that okay? So what you do is to write these brackets the way they have given us, the answer will be here it's 7 is closed, comma, then 13 is open like that. So this is the answer. That's why I use this bracket, this one, comma, this one, comma, this one, and this one. Ah, yeah. So like, show me the other one I should solve so that we forget this one. Which one should I solve? Ati? All right. So tell me which one. Okay. So number D, this is how we solve it. Um, you get the way it is here, right? Yeah. So you can see that this can be simplified. So we have negative 6 x. No, it's not x there. So negative 6 is less than or equal to negative 2x, which is less than or equal to 4. You can divide throughout so that you reduce. You divide throughout by 2. Is that okay? Is that okay? So say you say negative 3, then you, you just want to you just want to simplify this because it's big for you. Make sure that you remain with a number just like we remained with it like this. Yes? You, or you can just be walking, don't cut, because if you cut, it will be very difficult for you to join. So go, I've given you 2 minutes. You can go there. All right. So it's 2 minutes now. What if there are people that just stand wherever you stand? Yes, very soon will be done. Very soon will be done. All right. So you have asked me guys to solve number D. Sure. So what you are going to do is, all right. So I'll solve number D. So like you try by all means. The only way you can present on a number line it is when it is in this form. Is that okay? Like where X is single digits there. Is that okay? Like just like this one. That's what I want you. You try by all means to simplify. Is that okay? So since you said D, I'll say negative X. Mhm. So from there, then what we do is you divide throughout by what? What is the smallest number so that you remain. Make sure that you divide throughout by what is there. Like here, you divide throughout by 3. Here, you divide throughout is okay already here, but the issue is here. There. Sure. Yes, so that you remain with X on the middle there. Is that okay? Yes, so that you remain with X on the middle there. Is that okay? Yes, so that you remain with X on the middle there. Is that okay? Yes, so that you remain with X on the middle there. Is that okay? Yes, so that you remain with X on the middle there. Is that okay? Yes, so that you remain with X on the middle there. Is that okay? Is that okay? Yeah, you look at you like what is there and divide throughout by what is there so that you remain with a single x. That's the only way you can plot it like they have done there, so that you get to have you get to have a clear picture. Is that okay? Sure. Dividing throughout by 2 here to give us what? Tell me. Okay. By the way, I need to tell you something. I need to tell you something. Whenever you divide these intervals by negative, you need to be aware of something. Is that okay? When- Okay. s- Okay. Suppose you have negative, like you have an interval like that. X is equals to, let's say, 4. So whenever the moment I divide throughout by negative, this has to change the condition. It means that the negatives are less than 4, whatever number I put there. So this means that if I'm to divide throughout by 2, this means that I, I mean by throughout by negative 2. So x will be, it needs to look like this. Is that okay? Is that okay? Yes, because the condition was that x is greater than or equal to when x is negative. But now I want to make it positive, meaning that this will change to this side as well. Is that okay? So this means that I'm divide throughout by negative 2. Is that okay? This will give me x. Then here it will be divided by the negative. So meaning that it will be negative 6 divided by, or let me just say, we since we have grown up now, we know these mathematics. So what I'm going to do is, we know the answer that is supposed to be there. If I'm to divide throughout by negative, this will be positive, right? Positive 3, right? Then the sign will change now to this. Is that okay? Then there we'll have x. Also there it will be negative, so the sign will change to this, and this will be negative 2. Is that okay? Good. So this means that looking at the way it is here, see, it's saying, x, I think the negative should be on your left side, right? So I'll report it like this. Is that okay? Like the way it is here. Yeah, the negatives are this side, then the positive are this side. So the positive should come this side, the negative should come. How do I do this? I'll say this negative 2, it was less than x. You have seen? I've changed nothing. Yes, this time yes, again it is pointing to it like that. I've changed nothing there. Don't get confused. Okay, so it will look like that. Then also this x, this 3 was pointing 3 like that. So I'll do this. 3 was pointed like that. Is that okay? Yes. So I want you now. You see that at 2 it is closed. There's this part you have seen. It is dashed. So good. So this means that negative 2 it is closed like that. Is that okay? Comma. Again at 3 it is also closed. Is that okay? So if you are to present on a number line, you say we have negative 2 and 3. You cross them like that. You dash them like that. This is on a number line. As intervals, you write them like that. Yes, yes. These are all crossed intervals. You can be asked to say show it on a number line, but those are simple questions. So I know they can't. These are just for the sake of practicing. We'll be doing the questions if you want in my test one. I'm there for you. Then even in my chemistry part, we'll be doing everything. So now that is it. Even equally this one, you do the same. Hi. Not if you what you gave me attention, Shania. Up, you even got like, how do we solve these? Light each of the following intervals in set, build, and reset. Hey, this is what I was saying. Anyway, these are not that hard, but is there any hard question here that you're able to say? This one, this one. By the way, set build annotation. First, let me demonstrate for this one so that you see what is happening. A set build annotation is a notation that will be say x. The numbers on the number line they are called real numbers. So I'll say x is a member of real number lines, or I mean real numbers. Those numbers on the number line. Then then I'll say dash. That's what you like, that's what we do. You dash like that, then you give the condition the way you were doing the previous ones. So you say, okay, it was like this in the bracket. This means that we have negative. We start with the negative, and we'll say we'll put the sign there, and also x, and also I'll put 1 there. So you can see that they are all we don't know these numbers like here, these ones. It means it's not equal to. Is that okay? So this means that x, in short, x had the range from 1 to -1 like that. So they were all open like that because they didn't use these brackets. Is that okay? So this is how we write on the set build annotation. We say x is greater than 1 because x, yes, it's greater than 1 when you go this side. Again, the same x can be less than, so x is playing within this boundary. Is that okay? So we say -1 is less than x, meaning that we are going this side when it is less than. Then again, the same x is what? Is less than 1. Is that okay? Because we are in between x. Let's say these are the values of x that are in between here. So these values of x, they can be, because it's not crossed. Here it is simply means the value of x can be, um, let's say can be, suppose here it's 0. Here it can be 0.99. You have seen negative 0.99 here. Then here it can be also positive 0.9. These are the values of x. They don't touch these. That's the meaning of these open intervals. Sure. So if again I'm to demonstrate the second one, let me demonstrate this one for infinity. Here you definitely, here you definitely use that one which does like that, right? For this interval. And here I want you to solve this one. So I'll need the answers. Then coming to this one, the intervals, they are all open like that. So we have open like that. So we have 3 there, and also infinity is what? Is not cross. So you just bring to say x is a member of natural numbers such that such that x, you have seen that they are all going this side. You have seen. So we just say x, is that okay? Is greater than 3, because it's greater than 3 at this point, meaning that all the x's they are what? Or you can say x is a member of natural real numbers, then 3 is less than x. Because all the infinity they will be going, there is no number here. It can be 1001, 1000 so we are not like confined here. It's a broad perspective such that x, all the x's, all the numbers that are greater than 3 are what we list there. This is the meaning of this. And let's say we had the last number as 1000. That 1000 will still not list it. We'll say, okay, 1000, but we'll also open it, meaning that we can have again 10,000 there, and again we'll still open it. That's why I said we list like that. Mhm. We don't list the infinite. I would have said 3 is less than x, and again x is less than infinity. But we don't put infinite on this. We just last like that. Is that okay? You can write this way, but I don't think it's making sense. Such that 3 is less than, because it's not closed. And also infinity is not closed because we don't know it. But I can't list it because we don't know it. So I'll just give this to say x. All the x's should be just greater than 3. They should go either to 10,000, 19,000. But you can list in this way if you want to picture it in that manner. To say, okay, 3 is less than all the x's that we have. But again, the same x should be less than infinity. But we don't list infinity like this. It's not even looking nice. The handwriting itself can tell. Somewhere banko inviting you but there. Mm. So that's what you do with this. Even this equal to this one, you need to do that. But here it will be close. So I want you guys to. Is that okay? So like display each of the following on the intervals. This is what I was doing now. For this one, you say you have 10 there, and also negative 10. So on the intervals, you display like what? Of so, or it will be open like that. So say open, then here close like that. So you shade them like that. You do this. You write a line. This is a number line, but this is the line you are representing. Yes, the line is the interpretation, but this is the number line. Number line shows the digits. So here I can do this. I can do also this. It can even go to 11, but yeah, these ones, they are one they have given you, they're enough. So equally this one, you do the same. You just look at the negative part. If I'm to do C, I'll say negative 1 there and 5. Then if I'm to shade, here it's open, here it's closed. As it were. So here what you do is you put positive infinity, negative infinity this side, and also here positive infinity. Okay, is that okay? So if I want, I can say, okay, I'll just draw like that. We don't know whether it was going because infinity is not a number, so it can be on the other side, just like that. Ugh. So going to the next question. Um, you are okay. So this is where it is now mathematics. These are the questions they bring. Like in all what we have just solved, this is what they bring. We'll be solving. I have papers. We'll be solving Yama papers. I have most of papers. Yama session and stuff like that. So now here it's I think you guys are even okay. Let me just show you what is happening. I'm sure I've solved these intervals. Okay, what is happening here? Let R be the real numbers, be the set of universe A and what and then that. We have the list. This is the universal. I mean, no, this is C. Illustrate each of the following set on the number line. Hence, find each of the following. So here we'll show it on the number line. They are marks, and also this one on the number line, and also this one on the number line. Then you'll be given marks for that. Is that okay? Okay. So what we do is, so here you have seen, you look at, for you to find the universal, you look at what you have there, like the list negative. The list negative I have here is what? -6, you have seen. So I'll put here -6. The followed list number is what? -9, right? So -9 there, I'll put there. Do we have another negative number? Okay, so meaning we are coming at 0, right? So the next number which is positive, the smallest number is 1, right? The next number which is positive is what? The next number which is positive is what? Okay, so these are the numbers that we have, right? So this means that if I'm to list A is that at negative who? So I'll say, yes, I'll put there and also at 1. So by the way, in A, is the 6 closed or open? So what about at 1? So you cross like that, then you shade like that. Okay, so that is A. Is that okay? So then coming to B, B it is at 0, right? In fact, it is shaded. I've even done that, even at 5, right? Is that okay? You write straight. I'm just letting it shine. It's because of my handwriting. Then coming to C, C is giving a condition to say it's a set of U numbers, and C to say yes. So this means that we have -9 greater than or equal to x, and is less x is less than what? 8. Is that okay? Are we there? Hello? Okay, my network has some issues. Yes, let me just switch off. Someone was. Yes, it's my network. Let me pause it. Someone was calling. Okay, I've crossed. Is that okay? Yes, I'm getting you. Are you able to get me? Hello? Are you able to get me? Hello, guys. Are you able to get me? Okay, okay. I'm able to get you. So, okay, yeah, someone called. I've blocked them. So, what? Yes, someone. All right. So here, what we do is, um, looking at this, the condition is that we need to have members of X. Yes, they must be less than 8, and so find that numbers that are less than 8, we have all these numbers like 7, 6. You have seen? Yes, until -9, like that. Is that okay? We have 0 at some point, then negative until -9. So yes, we list. So it's more like we have -9, which is equal to the values of X. Is that okay? Yes, what I'm trying to show you is that I just want you to picture that the way we list this one, we need to have two members. So I can say at 9, all the x's which are are you getting me? All the x's which are greater than 9, we'll list them. So until 8 there, we'll just end at 7. Okay? So I can put 7 there. Yes, so I can put 7 and say at 9, I'll start from 9. 9 will be closed, right? And for 7 is, yes, I'll put 7 because it's what? In fact, let me put 8. Let me just put 8, what you have been told, but I'll open it. Is that okay, Abishai? Forget about what they, yes, forget about what they didn't show there. So just open it because it's not included in this. Is that okay? This will be our set C. Okay, so yes, I'll show you this one, then the rest you do them. I know they are complicated, but the next one is so that I don't share, so that you rest and you solve them. I don't have to eat a lot of time. So what I'm going to do is we'll solve this one. This one simply means A intersection C complement, right? Right? Okay. So what we do is we get A. A is this one, right? Then the complement of C is all this part. The complement of C is going this side, like we have going this side And here it will be closed for the complement because it was open for the set. Here it will be open for the complement because it was closed for the. Is that okay? So this is C complement and also this is C complement. This is C what we have there. But the C complement, it will be starting from here going aside like that. Upside. Upside. Yes, this is where it is getting tough. Yes. So what I'm saying is this is the C that we have there. Is that okay? Is that okay? Now, what is outside a C complement is what is outside the C. That's why I've written like that. These are C complement, showing the direction that is going. Now that C here it was open, meaning that in the complement it is closed. It's more like C had 8, which was open, okay? Meaning that is 8 wasn't part of C. Now it will be the part of what? Going this side. Is that okay? Yes, the number can only be shared at once. Yes. So if you have hands, you eat shima. If you don't have hands, you go this side. Is that okay? Ah, me nsima me pala. Anyway, I do manza. Okay, okay, okay. Some people listen, guys. Some people will be watching these videos. I know you share even to your friends. So let us not talk about Tonga, yeah. So other people will be from different universities. They'll be watching this because I'll post on my YouTube. Then yes, that is it. So we are solving this part here. So now I want to see where they will intersect. You know A is here, right? At this point there's A, and also at this point. Is that okay? Is that okay? Yes, so this means that A will intersect with C complement at this point because the intersection will be in this boundary of A. Is that okay? So here they are intersecting. So we are saying at C, remember now, all the elements now that were in the complement of at 9, they are not included. Okay? So even in my listing here, the complement also, this 9 won't be taken because it was part of C in the first place. This complement, this 9 was a part of C. So here I'll write like that. I'll open it because it was a part of C, but in the complement is not found unless if it was part of that and also it was also here it's a part because here it's not closed. So we don't know whether this A was ending at negative 5 or negative what. We don't know, but they just list here. I know here it's confusing. We'll do this like more questions. In fact, the next day I'll do maths is to do these ones because are the one they bring on the exam. These only. Okay. Yeah, the next time we do maths will be like once we are done with this, then we'll be very well and okay. Yes, so then what I'm trying to say is that at six, at 6, what will happen? At 6, this means that it will be closed because here it was open, meaning that all the answers that we had here, it's possible that um, they are meeting with A, right? In fact, let me do this. It's open because A is not closed here. So 6 is not part of that. But if A was closed here, I mean 6 was closed, A was closed here, it means it would have included 6 because it's outside the C. I know it's confusing here, but what I'm trying to say is would have included if would have included 6 if this was shaded. Now it's not shaded. So how do they intersect? They all intersect, but they are intersecting where it is not shaded. So it's not part, this 6. So then I'll do union like that. Yes. So then coming to this side also, we have where C actually intersect. Do is C intersect with A? They don't, right? This side A is ends at this point. Yes, they don't intersect. So this part is not there, so we'll just do with this one. I think on this one, let me not say a lot, you'll be tired. So this hint that I've already given you, just know that if you have found two sets and this one, let's say it's closed and here it's open and there's a number, let's say 2. This means that you can only list these two if we had the complement, like the complement was the complement. Let's say this is A, this is B, because the complement of A, it will be shaded. So you only list the two if they are shaded like that. If it's not part of the other set, and then the complement was a part. Anyway, I'll explain more about this, but I want you just to have a bit of idea then, so that when I start explaining there, it won't be a problem. But this is where it's a challenge. I know this is a challenge, but I promise, like, let me promise you that you get to understand this. When you start my questions, I'll bring my, like, I'll pick about eight questions from past papers, and we'll be able to. All right, so that try these ones, rearrange this one, and also do the same. Hi, yeah, I know it's like you're tired, but don't worry, don't worry. Let me also explain what you need to do there. Here is still also the same case. Try first. You will find each of the following. First of all, shown the number line the way I demonstrated. Then try to find the end of this. Then we'll see from the next lesson. Is that okay? Because I know you are tired. You're from listening a lot of things, like what I explained. You have seen there. You have seen Vasop. Yeah. So this it has been saved, and